Okay, let's take a look at how to solve trigonometric functions. So first of all, when you see a function, you want to decide whether the function is linear or quadratic. So if it's linear, then you just solve for the trig function and then look at the corresponding angles. If it's quadratic, you want to see if you can factor it or use quadratic equation formula. So always try to see and rearrange it. If you can factor it, make sure you solve it for 0. And if you solve it for 0, then factor it, then set each factor equal to 0, and then solve the many-factor equations and look at the corresponding angles. So let's take a look at a problem. So here we have tangent x minus 1 times square root of 3 cotangent x plus 1, and that is equal to 0. So that this is equal to 0, this is really your indicator on how to solve this. We have to use here the zero product property because basically it is factored for us already. So we set each one of these parentheses equal to 0. So the tangent of x minus 1 equals 0, and the square root of 3 times cotangent x plus 1 equals 0. Now we'll solve each of these equations for the trigonometric function. So that means you add 1 to both sides. Tangent of x equals 1. Here we're subtracting 1. Get negative 1, divide by the square root of 3. And you have the cotangent x is equal to negative 1 square root of 3, and if we rationalize the denominator, that would be negative square root of 3 over 3. Now we're looking for the angles. For which angle is the tangent positive 1? So I always like to make my little triangles. So the tangent is positive 1 in quadrant 1 and in quadrant 3. So we're looking up our angle in quadrant 1, x equals, so for which angle is the tangent equal to 1, and that would be pi over 4 in quadrant 1, and in quadrant 3 that is 5 pi over 4. So compared to the inverse trig functions, we're looking for all values here that give us the angles. Actually, we have a restriction. We're going from 0 to 2 pi. So we're looking for all the angles between 0 and 2 pi, but 2 pi is a parenthesis, so 2 pi is not included. We're looking for all the angles in this interval. While when we looked at inverse functions, we only looked at one angle because we had to make sure that the function we were looking at was 1 to 1. So here we don't do that. 1 to 1 means we had to restrict our domain and range, and that's why we only looked at 1. So now we're looking to when is the cotangent of x negative square root of 3 over 3. So the cotangent is negative in quadrant 2 and in quadrant 4. So I'll just draw a little picture here in quadrant 2 and quadrant 4, and that means our angle is 2 pi over 3, and in quadrant 4 it would be 5 pi over 3. So our solution set is what you have to enter in my math lab is pi over 4, 5 pi over 4, 2 pi over 3, and 5 pi over 3. My math lab likes to go in order, so from the smallest angle to the largest angle I did not do that, but if you want to do that, it would be pi over 4, 2 pi over 3, 5 pi over 4, and 5 pi over 3 from quadrant 1 to quadrant 4.